Sup guys, welcome to today's show. Today we are gonna answer this question. Why 755? You have probably sometime used the command chmod 755 and the name of a file or a directory. But what does this 755 mean in detail? This and more we're gonna talk about today when we are discussing Linux file system security. And this topic will be divided into the following different things. We are gonna talk about file permissions. And that also is applicative to directories and is a huge part of the Linux and Unix security. We will also discuss the different targets that you can set these permissions for, and we will also discuss the chmod command in detail, how to use it, and if we have time left I will also mention the change own command. Plus I will be teaching how to view permissions as well. So let's start with the different permissions that are available on a Unix and Linux system. So first and foremost we have read, and read is what it sounds like. If you have the read permission on a file, you can open the file and read its file contents. If you have read permission on a directory, you may list the contents of that directory, all the file names. So read has the character flag of R, and that is important when it comes to the configuring of permissions using the chmod command, and also while viewing the permissions. But there is also a numeric representation of that R flag. So for the read permission, that is number 4. And there is also a binary representation, but I'll get back to that in a little while. Then we have the write permissions, and that is a W as a flag and number 2 in the numeric representation. So what is the write permission? Well, if you have the write permissions on a file, you may edit the file, alter the file contents and save the file. You may also delete the file. And if you have the write permission on a directory, you can do basically anything, almost. You may delete files, you may create files, rename files. But there is also a third very important permission, which is called access. And that has an X in the flag representation and a number 1 in the numeric representation. So what does access mean? Read and write permissions are quite similar for directories and for files, but access differs quite a lot. So if you have the access permission for a directory, you may enter that directory. You may access the directory. So basically it means you can cd into the directory. If you only have the access and not the read, you may not do ls and show the contents of that directory, but you may access it and you may go to subfolders if you know the name of them. And if you have the access permission on a file, on the other hand, that means that you may execute that file. So executing a file, that's basically when you run a script or when you start a program. So, for example, the ls command is a program. If you have the X flag, you may run the ls command. Otherwise, you'll get a error message saying permission denied. So that is basically it when it comes to permissions. But I also want to talk a little bit about their binary representation. So let me just scroll a little bit. Okay, so why are we talking about binary? That is because I want you to understand how this system is constructed. It's a very, very intelligent system, which are based on those flags. So this kind of flag system is not only used for permissions, it's used for a lot of different things in the Linux operating system, but also in a lot of low-level code like C programming and stuff. And you will soon understand why. Okay, so if we convert the number 1 to binary with 4 digits, we will get 0, 0, 0, 1. Okay? If we convert the 2, we will get 0, 0, 1, 0. And notice that we don't have a 3. We have a 1, we have a 2, and we have a 4. Why is that? Well, if we convert the 4 to binary, then we get 0, 1, 0, 0. So a pattern emerges. What we can do is we draw a line right here and right here, and then we see that all those ones are in different columns, which means that we can combine them as we would like. So let's say we want to combine the read and the write permission. That would be the number 4 plus the number 2 equals 6. So if we give the number 6 when we configure the permissions, it will set both these two flags. And if you use the ls command to check the permissions, then it only needs this 6, because if you look at these three numbers, 1, 2, and 4, the only way to produce a 6 is by using the 4 and the 2. And that is true for all possible combinations of these values. As we can see here, the ones are in their own column. So if we set this, or if we set this, or this, it won't alter these ones. And what does that mean? Well, it means that with one single integer, we can basically store as many flags as we would like. At least up to 4.3 billion or whatever. And we can store all possible combinations of these flags as well in one single integer. And that is a very, very powerful way of storing data. Okay? The next thing we're going to talk about is the targets and the output of the ls command. And let's start by talking a little bit about the targets. Because we have these permissions, read, write, access. But who do we give the permissions? What do we set it on? Well, we have, for every file and every directory, we have 3 different alternatives. We have the owner, and that is also called the user. We have something that is called group, and we have other. And these are kind of self-explanatory. The user, or the owner, that is the owner of the file, basically. So if you have created a file in your home directory, for example, then you are the user or the owner. And that means that you're allowed to change the permissions. If you remove all the permissions, then you cannot open the file. But you may give yourself read-write access and then open the file. You can also delete the file and stuff like that. So you need to decide for every file and every directory if the owner should have read or write or access or any combination of the 3. The same goes along for this group. So every user on a Linux system is a member of at least one group, but possibly several. So basically the administrator, the root on the system, may create those groups. And you can be a part of one group, or you can be a part of thousands. And you can be part of named groups, or simply a numeric representation. If you set permissions for a specific group, then you have endless possibilities. Because if you just have these 3 different levels, the owner, the group, and other is just applicative to those who are not the owner and not a member of any group. So it's a very simple system with small building blocks, but you can create really powerful things with it. And we are going to talk a little bit about the flags of these targets as well. So let me just put them down here again. So the user is the official name for this owner of the file. So I will call it user from now on. But sometimes it's being called the owner as well. And then we have group, and we have other. So it's very easy to remember those flags, because the user has a U, the group has a G, and the other has an O. So when you set the permissions, you have the possibility of using these flags to specify the target. But there is also a combination of all these, which is the A flag. And that basically stands for all. So it alters all these three targets and sets the permissions you specify. Okay, what else? Well, you may also use combinations of these. So if you want to set for the user and the group, you just do UG, or other and group, OG. So easy system, but kind of simple to use anyway. Another thing I'm gonna do is I'm gonna color these different targets. So the user will be yellow in this example, the group will be green, and the other will be purple, or possibly pink. And then I'm gonna zoom out a little bit so we may see everything here. Okay, so if you do the regular ls command, then you will only see the names of the file by default, unless you have changed the default settings by an alias or similar. But if you do like is shown here, ls-al, and this is an L, a small l, not a 1. So ls-al, then you get one line per file or directory, and you get some additional information, like the day it was altered, and the size of the file, and stuff like that. And then we have the names to the right. But the thing that is interesting in this example are these right here. So perhaps you have seen this before but haven't given it much thought. These are the different permissions. And it might, if you look, if you're not familiar with this, it might be difficult to make sense of this, because it's just a lot of different characters, and you may not see any pattern here. But let me do this. If I take my yellow pencil and I highlight this part, and I'll take my green and I'll highlight these, and finally I will take my purple or pink and highlight these, and then I will zoom out a little bit again. Do you see now? So in this example, if we look at the first file or directory, the etc, then in yellow we see the user's permissions. That's always displayed first. So the user has read-write access, and the next one is the group, and as you can see, there is read and there is access, but there's only a dash in the place of the write. So this means read access but not write. And same for the other at the end here. And if we look at the next line, there is the same format, but this time there is read-write for the user and read for the other two. Then additionally we have this lonely D right here, and that only means that this is a directory, and often you will be able to identify that because there's either a 0 on the size or the same number for every directory. Plus you can see this slash at the end in some implementations and configurations of the ls command. Okay, enough about targets. Now we're coming to the last part of this episode. Chmod. Chmod is the command for altering permissions on a Unix and Linux system. And you do chmod and then something and then the file name like test.txt. But what do you type in the middle right here? Well, let's say we want to give those permissions for the files that we see right here. So read-write for the owner and read for the other two. Then we have a couple of options. We may construct a string which looks like this. U equals read write group other equals read. So if you put this string in the middle here, then you will get those permissions. That's one way. Another way is to give all the read permission, and then the user will add the write permission. So this is a plus, U plus W. So there is a lot of possible ways to define those groups. If you leave out the A and the U, etc., and just do plus read write, then it applies to all three groups. And you can also do A equals nothing to remove all the permissions. I do that sometimes. So I run this command and then I specify like group plus R or something like this. Okay, that is one way, which is good to use when you are setting permissions that is not very common. But if you are changing similar permissions like often, there is an easier way, and that is using numbers. So now we come to this 755 stuff. What does 755 mean? Well, the first number is the user, this is the group, and this is other. And if we go back to the first slide right here, if we combine the 4 and the 2 and the 1, then we get a 7, which means that 7 is read-write access. And the 5, well, there's only one way to construct a 5, and that is 1 and 4, of course. So read and access, that is 5. So this command means that the user will have read write, group other will have, no, the user will have read write access, and the group and other will have read and access. That's correct. So 755 is something you use a lot because you want to give access to directories and run permissions for scripts and programs. And another one which is very common is the 644. That means user, read write, group other, read. That is usually what a regular file will have by default. The directories most commonly have the 755 by default. And finally, another number which I use often on home directories is 700, which means I am the only one with any permissions to even access my home directory. What have we learned today? You have learned about Linux file system security, that there are 3 parts to it: the file permissions, the targets, and the chmod command. Let me say a couple of words about the change own, by the way. As you might have guessed, the change own command changes the owner of a specific file. So let's say there is a user called user5, and you want to give them the ownership of a directory. Then you do change own user5 and then the directory like etc or whatever. If you want to give a specific group as well, then you add a colon and then you type the name of the group. So if you have a group called users, you will type user5 : users. Today you have also learned about the read, write, and access permissions and their flag and the numeric and binary representation, and how you can make use of all of these, combine them in infinite ways. You have learned how to use the ls command to check the permissions and what these different characters mean. You have also learned about the 3 targets: the user, the group, and the other, which you are able to set permissions for any file or directory in the system. And finally, you have learned the chmod and the change own commands, which changes the file and directory permissions and the owner respectively. Okay guys, this was a new format using my iPad to draw those things. I think this is a good format for these kind of videos. Let me know what you think in the comments. And more C videos are coming up, so please subscribe by clicking the little red button on the bottom right on your screen if you want to subscribe. And thanks for watching, and thanks for today.